Hi, I'm going to talk to you a little bit today about how to solve a quadratic expression. Okay? When we're first presented with a second-degree polynomial like the one you see on the board here, we're often presented immediately with this thing that's called the quadratic formula. Well, that gives us the answers. Okay, in other words, those values of x which are going to make this equation true. But there's very little sense of where that formula comes from. And that's really what I'm hoping to accomplish today, is to show you a little bit about that. The Indians were accomplished mathematicians, including some of the ideas that we take for granted today, including zero, or a numeral standing for the quantity nothing, and the very beginnings of what we call algebra. Now, this particular solution, which I've got written up here, we'll go through these one at a time, but what it amounts to is taking a quadratic expression, going through a process called completing the square, and then what we do then is we simply take the square root of both sides, and then that'll give us the answer to our quadratic equation. Okay? Rather than reading a bunch of bullet points to you, let's just try by starting and showing you an example, and I can show exactly how the process works. Let's start with the equation x squared plus 12x minus 7 equals 0. Notice that the coefficient of the very first term, the x squared, is actually just 1. What we're going to do is we're going to move the minus 7 to the other side, and so we're just going to end up with positive 7 on that side. In the next step, we're going to transform the equation. We're going to take and multiply the entire expression by 4 times the coefficient of the first term. Now, since the coefficient of the first term is just 1, that means we multiply through by 4. You can see how this transforms the expression in the last line. We're now going to take the original coefficient of the x term, in this case 12. We're going to square that and add it to both sides. Now, the square of that particular coefficient is going to become important later. This is an essential part of that completing the square that I talked about. Let's take a moment to figure out what that term, completing the square, actually means. What it means is that we're going to be able to take the square root of both sides of this equation. In this particular case, 172 is just going to come out to be a bit more than 13. But what does it mean to take the square root of the left-hand side of this equation? Essentially, what it means is that we're looking for an expression of px plus q, where p and q are just these coefficients, that when multiplied itself is going to equal that algebraic expression on the other side, that left-hand side. So let's see how we can do that. In essence, we're going to take p, that's the square root of the first coefficient, and q, that's the square root of the third coefficient. My claim is that the expression 2x plus 12, that when multiply it by itself, is going to equal the expression on the left-hand side. We start in the first line by showing that 2x plus 12 squared is just 2x plus 12 times 2x plus 12. Next, we're going to use the distributive property of multiplication. We're going to multiply the very first term in the first bracket by the entire 2x plus 12. And then again, we're going to add that to 12 times that same quantity in parentheses. Then we're going to use the distributive property again in order to end up with 4x squared plus 48x plus 144. This is the form of the left-hand side of the equation that we had arrived at prior to the interlude. In short, we now know how to take the square root of both sides of this equation. Essentially, we have 2x plus 12 is equal to plus or minus, don't forget the positive minus root, plus or minus something a bit more than 13. On the screen in green, you can see we've taken the positive root and solved for it, and in the blue, we've solved for the negative root. Is there an easier way of doing this? Yes, of course. We've already shown you the quadratic formula. And so what we're going to do now is we're going to step through this process one more time, only we're not going to use specific numbers for the coefficients a, b, and c. We're going to use them as generalized coefficients. This whole process will be completely general and should work with any quadratic equation. Here we have the steps laid out one more time, steps A through D. So I invite you to step through these. Go ahead and pause the video and step through the whole process one more time. just making sure that it's going to work for any particular values of A, B, and C that you run into. Okay? This has been Stan Forrester, hoping that I gave you a little bit of assistance with quadratic equations, and good luck on your work.